We're going to add and subtract rational expressions. Remember, a rational expression is nothing more than a fraction with a numerator and a denominator that it's a polynomial. So the rules for adding rational expressions are exactly the same as for adding and subtracting fractions. The denominators have to be the same. So if the denominators are the same, like in our example here, we simply add the numerators and keep the common denominator. So in the example with the rational expressions here, since these both have an x to the fourth on the bottom, we simply add the numerators. 2x plus 4x is 6x. And we have x to the fourth as the denominator. Now, before we are finished, make sure that this is simplified. The x on the top will cancel with 1x on the bottom, and we end up with 6 over x cubed. Okay? Here's one that's just a little bit more complicated. The denominators are the same, so our denominator is going to be m plus 4, and we're simply going to add the numerators. Well, that means we're going to combine like terms. It's going to give me m squared plus 5m plus 4. And again, before I walk away from this, I need to make sure that it's in simplified form. I have to factor it to see if there's any common factors. So this is going to be m plus 4 times m plus 1. The m plus 4s will cancel out, and my final answer is m plus 1. Okay? And that's how that works. To subtract them, the same thing applies. It's just that you have to subtract the numerators. Now, here's where you have to be careful. This subtraction sign goes to this term and this term. Okay? I like to make it plus and then just go ahead and put the minus sign in front of each one of them. Then to put this together, I'm going to have y squared plus 4y minus 12 on the bottom. On the top, 6y minus y is 5y. And negative 6 minus 4 is negative 10. Again, I need to factor. Here I can take out a GCF. Gives me y minus 2. On the bottom, I can say that's going to be y plus 6 times y minus 2. And the y minus 2's cancel out. And I am left with 5 over y plus 6. All right, so we're using a lot of tools that we've used in the past. All right, let's try one more down here. Let's get rid of that. The one down here on the bottom, they have a common denominator. So I'm just going to go ahead and combine the tops. 5a, again, this is minus, so I'm going to make a plus, the opposite, the opposite. 5a plus negative 2a is 3a. And positive 2 plus 4 is 6. On the bottom, I have a squared minus 4. Let's factor to see if we can cancel anything out. Take out a GCF on the top, which leaves you with an a plus 6. This is the difference of squares, which is a plus 2 times a minus 2. All right. And what, oh, I made a mistake. Silly me. Let me go back and fix that. That is an a plus 2. And now when we go to cancel things out, the a plus 2 cancels with the a plus 2. And we are left with 3 over a minus 2. It makes it a little more difficult if they don't have a common denominator, so you have to have a common denominator. All right, we call it the least common multiple. To find that, factor your terms, and then any factor that they have in common, take the greatest number of times that it appears in either one of the expressions. So for instance, 6x squared is 2 times 3 times x times x. 8x is 2 times 2 times 2 times x. Well, they both have 2's in common. The greatest number of times that they occur is 3, so we're going to use that. The 3 they don't have in common, but we're going to use that. And the x's they have in common, so we're going to use 2x's because you take the greatest time that it happens. That means the least common multiple is going to be 24x squared. If you do this with polynomials, you need to put them in factored form. So I factored this one. It's going to be 5 times x plus 3. and this one is x plus 3 times x minus 3. All right, now 5. They don't have a 5 in common, so we just bring it down. They both have an x plus 3, but it only occurred one time, so we're going to bring that down. And then they do not have an x minus 3 in common, so we're going to bring that down. This is my common denominator, my least common multiple. Okay, so I want you to find the least common multiple of these. Okay, pause the video and then we'll look at it. Okay, so I factored this out, okay, and here are two 2's, so I'm going to use those. That's going to be a 4. Here they have 3's in common, but this one has 2 of them, so I'm going to use that, which is a 9. X's, I'm going to use these two, so that's x squared. And y's, I'm going to use these, which is y cubed. So my least common multiple is going to be 36 x squared y cubed. Okay, try the next one. Remember that you need to factor first. All right, I factored both of these polynomials. You notice on this one I pulled out a 3 first, a GCF of 3, and I was left with a perfect square trinomial, so here it is. All right, now, do they both have a 3? No, so I'm going to write it down. Do they both have a c plus 5? No, so I'm going to write that down. Do they both have a c plus 3? Yes, they do. In fact, this one has 2 of them, so I'm going to write both of those down. And that is my least common multiple. All of that is my least common multiple. So now we're going to do the same thing, but we're going to do that in order to get a common denominator. All right? So I'll do one, then you do one. Okay, actually, go ahead and try this one first on your own. All right, ready? 5 and 2. Those are not the same, so that's going to give me a 10. Okay, n's, they both have n's. The most that they have is 3, so that's n to the 3rd. So there's my common denominator. Now, what I need to do is I need to go back and figure out what I need to multiply by in order to make that happen. So in this case, I'm going to need to multiply by a 2 to turn that into a 10n cubed, which means I have to multiply the top by 2. So that's going to give me 4n over 10n cubed. And what I need to multiply this one by to turn it into that, I'm going to say a 5n, which means I have to multiply the top by a 5n. So that is going to give me plus 20n squared over 10n cubed. Now that the denominators are the same, I'm just going to go ahead and add the numerators together. I like to put them in order. 20n squared plus 4n over 10n cubed. Need to factor this. I can pull out a 4n, and that's going to leave me with a 5n plus 1 over 10n cubed. What can cancel out? This n will cancel with this and leave me an n squared. 4/10 can be reduced to 2/5. So I end up with 2 parentheses 5n plus 1 divided by 5n squared. Okay? Now when you look at this second one, I'm hoping you're looking at these thinking, that looks like so close to being the right thing, but really not. You can make these denominators the same by using a negative 1. Now, it really doesn't make a difference whether you multiply the first one by negative 1 over negative 1 or the second one by negative 1 over negative 1. You can also change this by changing this to a plus and taking the opposite down here. Okay, again, that's totally up to you. I think probably the best choice would be to do this, to multiply this by negative 1, multiply this by negative 1. That's going to give me negative 2 over, change both these signs, w minus 5, plus negative 5 over w minus 5, which is going to give me a negative 7 over w minus 5. Okay? And just again, remember, in order to be able to find a common denominator, I have to see what factors they have in common, which means it would have to be factored. So this is going to be a minus 2 times a plus 4. This one's already a minus 2. So what do they have in common here? A minus 2. And what do they have that's not in common is an a plus 4. So that's going to be my common denominator. Okay? Well, this one's already good. He's already set up because I've already got it all. This one needs an a plus 4, which means you're going to have to give it an a plus 4 on the top. Okay? All right, so what is that going to give me? Let's see. Let's go ahead and make these denominators the same. Lots of times I'll just write it over one big denominator. Okay, so the first one's going to stay the same, a squared plus 4a. The second one's going to become 8a plus 32, which when I add those together is going to give me a squared plus 12a plus 32 over my denominator of a minus 2a plus 4. Okay, let's see if we can simplify this at all. Let's factor this. I'm going to say a plus 8 and a plus 4 in factored form. What can cancel out? An a plus 4 with an a plus 4. And there's my answer. A plus 8 over a minus 2. Okay, that's it.